Hello there. Welcome back again. Today we're going to go over a topic called time value of money. This is the basic tools for finance and is also very useful for financial planning. So let's get started. So what is the time value of money? There's an old saying that says $1 today is worth more than $1 tomorrow. The question is why? We mentioned in the last video that there is a impact of inflation on your purchasing power. So $1 today, you can purchase what you can purchase with $1 today. You may not be able to purchase the same amount of things with $1 in the future because of inflation. The other is risk. $1 today is a bird in hand, whereas the future is uncertain. So the payoff, you may or may not receive that $1. And the last reason is opportunity cost. This is an economics concept. So basically, the idea behind opportunity cost is that if you are delaying your consumption, so you're putting money away in an investment account or a savings account, so you cannot buy something today. So that is in addition to inflation. So you're delaying, you're sacrificing the utility that you will get from either the goods or services. So for example, not taking a vacation, that you should be rewarded for. And also, if you're investing in something that is risky, then you should get rewarded for taking risk. On the other hand, another way to look at opportunity cost is that if you spend the money today, so for example, you take that vacation or you go out to eat in a restaurant today, that will mean that the money you spend on that particular item or entertainment will not be available for you to invest and earn interest. So therefore, how much you want to save versus how much you want to spend, you should take into account what are your current needs, what is the uncertainty regarding what may happen in the future, and also potential return on your investment. So there's no set in the stone rule in terms of what is the best for everyone. We have to take into account your personal circumstances and your personal values. When we talk about time value of money, the most important concept is compounding. So compounding means that we assume you will not take the interest out, you will allow the interest to accumulate, and therefore interest is computed based on the most recent balance. So compounding means that you are earning interest on interest. Let's take a look at a very quick and simple example. Let's say you have $1,000 and you can earn 10% per year. So the interest in the first year will be $1,000 times 10% or 0.01, and you'll get $100. And when you add the interest, the $100 interest, to the original balance of $1,000, you'll have $1,100. So let's say you leave the money in the bank for another year. How much would you earn in the second year? So first, let's take a look at the interest that you earn. So you earn 10%, but notice that is 10% on $1,100, not $1,000, because your new balance in that year is $1,100. So 10% of $1,100 is $110, and then the balance going from $1,100 plus 110, that will give you your new bank balance. So 1,100 plus 110, after 2 years, you will have gone to $1,210. To better understand the effect of compounding, we need to introduce a concept called simple interest. Simple interest is when interest is not reinvested. So what that means is once you get your interest, you spend it. There are also some consumer products that pay simple interest. They are not very common at all. But this is simple interest means that when you earn interest, instead of letting the interest remain in your investment and continue to compound, you take out your interest and spend it. So the balance is assumed to remain the same. No interest is added to your original investment. So let's take a look at how that will affect your overall accumulation. So let's say you invest the same $1,000 at 10% per year, but this time it pays simple interest. So the interest is still $100, so it's still at $1,000 times 10%. So that still gives you $100 in interest. But since you're not letting the money to accumulate, the next year you'll earn the same $100. And after 2 years, you will have a total of $1,200. So it's the $1,000 original investment plus $100 per year in interest over 2 years. So $1,000 plus $200 gives you $1,200. So what is the effect of compounding? Compound interest is defined as the difference between the balance if you reinvest your interest minus the balance if you just have simple interest. So in our first example, the balance after 2 years with invested interest is $1,210. And if you have simple interest is $1,200. And the compound interest, or the difference, is $10. And this $10 come from interest on interest. Because we earned 10% interest in the first year, we left that in the bank earning 10%. 10% $100 is $10. So $10 is the difference in this case. It may not seem much, but remember, this is only for 2 years. The power of compounding is most powerful when we take into account multiple years. So let's say the same example, still at $1,000 at 10%, but now we let the money stay in the bank for 30 years instead of just 2 years. The balance after 30 years with compound interest or reinvesting interest is $17,450. If you don't reinvest, the balance will only be $4,000. So compound interest in this case is over $13,000. So the power of compounding is most significant when we are talking about long-term investments, 10, 20, 30 years. Now let's take a look at a little bit more about compounding. In addition to the power of compounding, it's also important to take into account the compounding frequency. Compounding frequency simply refers to the time unit. So whether or not we are talking about per year, per quarter, per month, per day. So compounding frequency means how often is interest computed, because each time interest is computed, your ending balance will go up. Because each time interest is computed, the interest is going to add to the ending balance, and then the next time's interest will be based on the higher ending balance. So if compounding frequency is once per year, that will be annual compounding. If it's quarterly compounding, that means it will be 4 times per year because there are 4 quarters per year. Monthly compounding will be 12 times because there are 12 months. Daily will be 360 times, and so forth. There is a special case in compounding, and that is continuously. That is beyond the scope of this course. However, we want to let you know that there is this special case. So why is compounding frequency important? The reason is that in finance, compounding frequency usually coincides with payment frequency. So for example, you take out a loan, do you have to pay, is the payment monthly or is it bi-weekly? If you invest, do the company pay dividend once a quarter or once a year? If you buy a bond, do the company pay interest once a year or twice a year? So those are important things to take into account, because the higher compounding frequency results in a higher effective interest rate. The reason for that, again, is because every time you increase the ending balance, the next time period's interest goes up. So the higher the compounding frequency, the faster the ending balance go up, and the more the interest will be the next time. So if you have a Biweekly compounding, meaning you have to make biweekly payment or weekly payment versus monthly payment. The effective interest, the de facto interest on the weekly payment is higher than the interest on a monthly payment, even if nominally they are the same. So 12% with monthly payment is actually different from 12% with weekly payment. Next, we're going to look at the derivation of time value of money calculation. We're going to look at some formula, but do not be discouraged. We'll introduce the concept with the formula to show you how they are related to the example that we already seen. And then we're going to use tools such as Excel or Google spreadsheet to help us do the calculation. So you don't really have to work with the formula at all. But it's useful to understand where these tools derive their calculation from. First, we need to learn some definition, and these definitions are useful in all our future calculation, whether or not you're doing it by hand or you're using a computer program to do it. So present value is the term that refers to the value at the beginning of the investment horizon or the borrowing horizon. So if it's a loan, it's the amount that you take out today. If it's investment, it's money that you put in today. Future value is the value at the end of that time period. So again, I'm going to use the term investment here, but it can also be borrowing. Of course, if you're investing, you'll receive the interest. If you're borrowing, you'll be paying the interest. The compounding frequency, we mentioned that already, is how often interest is computed. So it can be once a year, 12 times a year, 360 times, and so forth. Time is the investment horizon. It's important to know that time 0 is today, so it's the beginning. And then time 1 is at the end of the first month or at the end of the first year. Rate refers to the rate of return or interest rate on the investment or the loan. So oftentimes we will consider when we're talking about investment, we will talk about the rate of return, whereas when we talk about a loan, we say the interest rate that we pay. So this is the basic time value of money formula. So once again, you don't have to memorize this, or we'll actually seldom use this, but it's good to understand why and also how this is derived. So basically it says that the future value, meaning how much you earn at the end of the investment horizon, is equal to how much you start with, so your present value, and times 1 plus the interest rate to the power t. So it's the interest rate compounded by the time period. So t is time period. So let's take a look at our last example, and we can then see how this works. Remember that we have an investment of $1,000, and M meaning that it's paid once per year, and it's over 2 years, we earn 10%. So this formula tells us that after 2 years, so future value, this investment after 2 years, you start with $1,000, you multiply by this interest factor, we call it. So in here, if you break this down, this is equal to 1.1 to the power 2, or 1.1 squared, and that is 1.21. If you multiply 1.21 by 1,000, you get $1,210, which is exactly the answer we get when we walk it through year by year. So it's useful to see this formula and reference it back to what we understand in terms of how we come up with $1,210. Once again, we're going to use this formula just to show you how it relates to simple concept and intuition that you understand. Next, going forward, we're going to use Google spreadsheet, which is the same. Also, you can use Excel to perform calculation on financial problems. So this will be the last time we'll see this formula. We'll pause the video here. When we come back, we're going to switch over to using a computer app to do the calculation. And I also prepared a template that go along with the lecture. See you back here soon.